Hello everyone, welcome to AWS reInvent. My name is Lakshman Malladi. I'm a software development manager in FinTech group at Amazon. I have with me Radha Krishna Ratnala. He is a senior software development engineer in our group. We are here to share our journey of how Amazon automated cash identification and matching of billions of dollars deposited in our bank account using AWS services. By the end of this session, you will have a better understanding of how you can solve a similar use case where you need high accuracy using AWS services, including artificial intelligence and machine learning. Here is our agenda for today. We will start with some introductions. For the audience who is not aware of cash application, we will briefly go over it. We will talk about the challenges we faced with this business process. We will share the solution so that you can build on top of it. We will briefly talk about the business impact that we delivered. Last, but the most important one, we will share our learnings and the best practices so that you can learn from our mistakes. Who we are? We are called Cash Services Team. We are part of FinTech Group at Amazon. Our team is responsible for providing technology solutions to accurately and timely process the billions of dollars deposited in our bank account and the millions of emails received by Amazon. What is cash application? In a B2 in case of a B2C solution, in case of a B2C customer, we charge customer's credit card or debit card once the goods are delivered. But in case of a B2B customer, once a customer utilizes Amazon services, we generate an invoice and send it to the customer. Once the customer receives Amazon invoice, since this is a B2B customer, they ingest that invoice into their financial platform. Once the invoice is ingested into their financial platform, they process the invoice and get it approved. Once it is approved by their internal teams, they will send an instruction to their bank asking to deposit funds to Amazon bank account. If their financial platform have flexibility to include the invoice information that they want Amazon to close, they will send that to their originating bank. If their financial system have capability to auto generate and send an email, they will do so as well. For the customers who do not have that flexibility, some customers manually write an email and send it to Amazon, and the email is received by the automation within Amazon. Once we get a statement from our bank confirming all the clear transactions for that day, the process of matching incoming payments with the remittance information sent either through the bank or through emails is called as cash application. In Amazon, if the whole thing is processed without any human intervention, we refer that as auto cash application. And when an auto cash application fails, it is manually handled by the cash application analyst within our finance operation teams, and we refer that as manual cash application. Some companies call this cash application process as cash reconciliation. Some call it as netting and deductions, but essentially it's the same process. At the outset, if you look at it, it seems like it is a simple pattern matching problem. But in an ideal world, if every customer includes the invoice information through the bank remittance or through a structured email, we will be 100% automatic cash application. But in reality, we receive remittance only for 52% of the incoming payments, and we receive 14% through emails as remittance, and we do not get quality remittance for almost 34% of the payments that we receive today. So to handle these 48% cases, we had to hire hundreds of analysts. Like with any other manual process, with humans, our error rate was higher at 8%. There are multiple reasons for this to be a complex problem. Some of them are specific to Amazon, some of them are generic across all companies who does this process, and some of them are dependent on the geographies in which you operate. Here are some of the problems that are specific to Amazon. The first and the foremost is the scale at which Amazon is currently operating. We send out millions of invoices per month. We receive billions of dollars deposited in our bank account. The rate at which Amazon is growing is another problem. We have double-digit growth in almost all the businesses that we operate in. We are not only growing in existing businesses, but we are also launching new businesses. With every new business launch comes a new business specific functionality that we have not dealt with before. So it is adding another layer of complexity. In the process that you have seen earlier, there are multiple stakeholders in this whole process. Customers AP department, originating bank, destination bank, and some customers are utilizing third-party vendors to manage their accounts receivable process. With so many stakeholders in this process, the data was getting lost in transmission between these stakeholders. In some countries, banks have limitation to send remittance beyond certain characters. Some customers ask you to log into their internal portals to retrieve the remittance. And unstructured emails containing remittance is a common problem faced by all the companies. When you operate in multiple countries and customers use your service across regions, it adds another layer of complexity. You send them invoice in one currency and they make a payment in a different currency. You will also see some geography specific behaviors, like in some countries, customers deduct the tax before they send funds to Amazon. And the tax rate at which they deduct will also change over a period of time. It's not all business process challenges. There are some technical challenges as well. Some customers take a screenshot of their financial transaction that they are sending to Amazon, and they attach that screenshot to email as an attachment and as a remittance text. So to extract data from images was a challenge for us. We have analyzed the customer payment patterns and built rule-based algorithms, but we were not able to scale with this reactive approach. Whenever we wanted to launch a new feature, validating the existing algorithms, and analyzing the impact of the new algorithm that we are launching has been a challenge for us. All right, enough of the challenges. Let's jump to the solution. Radha, the floor is all yours. Let's walk through how we solved it.
Thanks, Lakshman. My name is Radha. I'm a senior software engineer in Amazon FinTech Group. Let me walk you through how we solved this problem. These are the high-level tenets. We want to reuse the existing services as much as possible. We do not want to reinvent the wheel. We want to build a solution for Amazon scale and Amazon growth. Flexibility is important for us because we have multiple businesses and we are launching in multiple countries. We want to embrace the complexity to handle complex customer relationships. This is our formula, right tool for the right job. And these AWS services are our tools. These are the 4 fundamental building blocks in our architecture. Let me walk you through all 4 of them. The first one is serverless. We use serverless technologies to scale for Amazon growth. We used AWS Lambda to handle spiky traffic at the beginning of the month. We also get huge number of emails in the early morning of the day. AWS Lambda auto scales, and also we pay for only what we use. The second component in serverless is AWS Step Functions. AWS Step Functions is a function orchestrator, which is also a serverless technology. It helps us sequence the business logic across all these different lambdas. The second component is purpose-built databases to solve the complexity. We have built a knowledge graph using Amazon Neptune. We are using Amazon Elasticsearch for the text search. We are also using Amazon DynamoDB for faster lookups. The third component is machine learning. We are using artificial intelligence services and we also built our own models and then deployed using Amazon SageMaker. Machine learning helps us adapt to the change. The fourth component is engineering best practices. We are using Amazon CloudWatch for monitoring as well as observability. Configurability is very important when we want to enable features or disable features across multiple businesses or across countries. Business insights and analytics help us move ahead of the game. So let me walk you through how all these different components are integrated in our architecture. This is a high level architecture of how we process millions of emails, take the unstructured content and then convert it to structured document so we can understand what customers are trying to tell us. There are three components in this architecture. So first one is extracting the information from the email. Whenever we receive an email, we kick off a step function which executes multiple extractors in parallel for each attachment or the email body. One of the extractor is Amazon Textract. Amazon Textract is an artificial intelligence service for extracting the information for images as well as PDFs. It not only extracts the text content, it can also understand the form data as well as the tabular data. We use other extractors to extract information from HTML documents or Word documents or XML documents. Once we run all these different extractors, we take the text content that we received and then we store it in Amazon S3, which is a highly scalable and secure storage. We also store the email metadata in Amazon DynamoDB. When we are processing thousands of transactions in parallel, Amazon DynamoDB gives consistent performance or single digit millisecond latency for writes. So now that extraction is complete, we are using Event Bridge to decouple the analysis process from the extraction process. Step functions has a native integration with Event Bridge. Let's see how the analysis is done. So once the text content is available from email as well as attachments, we use Amazon Comprehend, which is a natural language processing service, which can understand the customer names or custom entities. We also get sentiment analysis from Amazon Comprehend. So once we get this information, we also extract the remittance information like customer name, invoice number, the amount customer is trying to pay, the date they have paid, that information. And then like we put it into a JSON document, which is structured content, which can be used for cash application. Imagine customer sends us an email saying that, hey, these are the 5 invoices that we want to pay and these are the amounts we are trying to pay. And then once we receive a bank transaction for that amount and then we see these are the 5 invoices you want to pay, we can actually close those 5 invoices and then apply to customer's open balance. We also store these results in S3. Event Bridge can trigger multiple processes in parallel. So not only we do analysis and cache application, we store this data in Amazon Elasticsearch for text search. So our users can search for emails using Amazon Elasticsearch. They can search for a customer name and then look at all the emails customer has sent to understand the context. Or if you received some money through your bank in bank transaction, you can search for the amount and then see like, hey, what are all the emails customers might have sent for this particular amount. Last but not the least is we use Amazon Kinesis, Firehose and Amazon Kinesis data streams for the analytics. We collect all the email analytics and then the attachment analytics to store into S3. We use Amazon Athena to aggregate these metrics and then we use QuickSight dashboard to show these business insights to our business users. For example, how many emails are used for auto cache application? How many emails are used for manual cache application? Which type of attachments we are able to process better? Which type of attachments we are not able to process better? We could actually use these insights so that we can go and like fix those processes, or we could go back to customers and say that these attachments can be sent in a better format. So this is how we process millions of emails and convert them into structured content. So let's see how we use this information for cache application. So this is the high level architecture of using all the information that we have and then processing the bank transactions. Let me slice it down for you. First step is preparation of the data. We want to take the account information, we want to take the invoices, we want to take the account relations, as well as the historic cash applications that have happened. And then we want to create a knowledge graph so we can understand how a customer is operating. We used Amazon Elastic MapReduce to transform this data that we have into CSV format, which can be bulk loaded into the Amazon Neptune. We also take the email data that we received in a structured format and then we store it in our Neptune knowledge graph. So we understand, given a customer, what are all the emails he has sent or which invoices he is trying to close and what are all the patterns that we have seen historically. We also store the data in Amazon Elasticsearch, like customer name, invoice number, and other information. Basically, we can set, sometimes banks send us partial information because there are multiple stakeholders involved, as Lakshman has mentioned. Some of the invoice information may be lost or truncated. We use Amazon Elasticsearch for those partial tokens and search for the actual invoices. An interesting challenge here is how to keep the Neptune as well as Elasticsearch consistent. Neptune supports Neptune streams, which is a change capture data, which we use to keep the Elasticsearch data consistent so that applications don't have to worry about how to write to two different databases. So this is how we have prepared the data. Now that the data is prepared, let's see the training process. We also take all the historic cache applications and then we use a SageMaker model and we deploy it to SageMaker endpoint for a machine learning model. Every day we kick off a trigger using Amazon Event Bridge and then we run a step function for the training process. We retrain the model with everyday's cache applications, including the manual cache applications as well. We are not only like train the model, we also do the validation for understanding the drift. So once we are happy with the new model and then we have done the validation, we deploy it for real-time references. So let's see how we process the bank transaction now that our data is in Neptune Elasticsearch. Also, we have the machine learning model available. So once we receive the bank transactions, we call the recommendation engine, which kicks off a step function for every transaction. We run multiple algorithms in parallel. Each algorithm can be a different lambda. We run remittance-based algorithms. If we receive invoice number or account number, we look into our knowledge graph and try to see what are all the invoices the customer is trying to make a payment of. If we receive partial information, we run another algorithm and then we kick off search with Amazon Elasticsearch to see if there is an invoice number that is open which is partially matching with the token. Sometimes we receive the bank transaction and if we only get like an invoice or account, we try to see has customer sent any email for this amount, which can be looked up again in the Neptune using the information that we have ingested from the emails. As Lakshman mentioned, sometimes we don't receive the remittance. In those cases, we are actually using the machine learning model to predict the customer account. For example, if a customer makes a payment of $10,000 to $12,000 every single month on first Monday of the month, then we know the customer pattern. And then next month when we receive a payment, let's say $11,000 on Monday, we know that this is one of the possible customers. Those kind of rules are possible with machine learning. So now that we have run different algorithms and then we have like accumulated the recommendations, we actually store those recommendations in DynamoDB and then we provide these recommendations for auto cache application if our confidence is very high. If the confidence is low, we provide these recommendations to our users and then users can pick one of those recommendations or they may like choose a completely different recommendation. We actually take these manual cache applications and then feed it to our machine learning model so that machine learning model can understand whatever our analysts are trying to do, and next time when it sees a similar pattern, it can be automatically identify the recommendation without the user involvement. Again, last but not least, we take all these metrics and then we use Amazon Athena and QuickSight to get business metrics and business insights. So we try to understand which particular business or which particular country auto application is doing well, where the automation is going down, which kind of transactions required manual intervention. These kind of metrics help us stay ahead of the game. So that is how we architected processing the emails and then processing the bank transactions. So let's take a deeper look into some of these services. So we solved complexity using purpose-built databases. These databases have something in common. That is, every item can be having a different schema. So that means when you have a new business or a new country launch, when you want to add new properties, you don't have to go back and update the schema. We used Amazon Neptune to for knowledge graph. So that means we try to understand all the relations from account to account and account to invoice, etc. So the idea is each database indexes the data differently for different query pattern. So Neptune helps us traverse the entire graph in few milliseconds. We used Amazon Elasticsearch for text search, and we used DynamoDB to handle the real-time transactions, giving the faster lookup. Let's see how we used AI/ML services. We used Amazon Textract and Amazon's Comprehend for processing the email content. We built our own custom model for predicting the customer accounts. I'll talk more about precision or reducing the false positive in the next couple of slides. So these are the Amazon engineering best practices. Configurability is the key because we want to enable or disable different algorithms for different businesses. So we used System Manager Parameter Store, which supports versioning as well as auditability. Automated testing is very important when we are processing the real-time transactions. So we have load testing, we have production parallel testing, unit testing, as well as integration testing. Automated testing coupled with configurability is the key when we are processing real-time transaction. You cannot just push the code and hope that it would work fine. Especially when the real-time transactions are processed, the data might go to the downstreams and it may be very hard to go back and fix them. So it is important that all these validations are done in pipeline before the code is pushed to production. Observability is also important, so we understand the operational health of our system right from the beginning. We used Amazon CloudWatch metrics and Amazon CloudWatch dashboards. Let's take a deeper look into the machine learning model that we have created and the high precision problem that we have solved. First of all, this is an extreme classification problem in the sense we get a bank transaction when we are trying to find an account in millions of accounts that are in Amazon. High precision is very important. That means like we want to be very accurate. We cannot take one customer's money and then put it in another customer's account. But at the same time, if you're trying to achieve 100% accuracy with machine learning model, we may be overfitting the model. That means it cannot predict a customer for like newly seen transaction. At the same time, we don't want to have low precision. So let's see like how we balance this. Again, real-time predictions are important. Even though the machine learning model is 100% accurate, if it takes several minutes, that's really not useful. We need something that can return the predictions in few milliseconds. So we have used KNN, K nearest neighbor algorithm. We have used other algorithms, and then finally KNN is the one which can scale for our volume. So in this specific case, the green triangle is the one which is a new bank transaction, and then we are trying to identify the customer accounts. Here there are 3 accounts: yellow, blue, and red. Clearly, when we say like give me 3 nearest neighbors, it gives you those 3 accounts, but red is an outlier. So that's a false positive. How do we remove that? We could reduce the k. We could say that don't use 3, just use 2. It could be very restrictive. It would give you the right accounts. But when there is a third account, which is a close neighbor, and then since we are very restrictive, we may be missing a positive. So if you are like too restrictive, you'll miss the good positives. If you are like lenient, you get the false positives. The way we solved it is using a distance threshold. Basically, what it means is find me the nearest neighbors only if they are within this distance threshold. There are like different kind of distance thresholds. It could be fixed or it could be adaptive. So that is how we solved some of the high precision problems. Even after that, once we get a list of accounts, we don't just take those accounts and apply to one of those invoices. We try to look into our graph database for those accounts and then look into those subgraphs. Let's say you got 4 accounts. We look into those 4 subgraphs and try to find an invoice that matches with the bank transaction. So you need these extra guardrails when you are using machine learning where high precision is very important. So this is a glimpse of our insights. So as I mentioned, we have these quick site dashboards where we can look at the different metrics. One of them is the algorithm behavior. We can see every day for a given business how a algorithm or set of algorithms are performing. Here you can clearly see one of those days the green algorithm has gone down and then the pink algorithm has picked up. So we are able to proactively see this behavior and act based on that. So that is how we solved the problem. We saw the building blocks, we saw how they are connected in the architecture, and then we also did a deep dive on our machine learning model and then the individual services. So let's see the business impact. We are able to automatically process millions of emails. Imagine the amount of time the analysts have to spend looking at each of those emails or looking at the attachments and the images. So we are able to automate that and then able to remove the undifferentiated workload from the analyst. So also it helped us save hiring like 1,000 people in 10 years. So they are processing the complex situations or complex scenarios, and anything that can be automated, we are able to automate it. Real-time insights and analytics gave us the trends and then also helped us understand how our business operates. Last one, this is very important. So we are able to do cache application 66% of time faster. So earlier it used to take 72 hours. Now we are able to solve it, or now we are able to apply the cache in 24 hours. This is a huge boost for customer confidence or customer satisfaction. Okay, let's look into the learnings and best practices. Right tool for the right job. So machine learning is not a magic wand. It won't solve all the problems. We need to complement with the other tools. We were able to use purpose-built databases to solve specific problems and then cut down the complexity. The second one is AWS is a game changer for us. We are able to use the manager services to handle scale or reliability, and then we were able to focus on the business problem, and then we were able to deliver this solution in months using like few team members. Experimentation is the key. We are able to like experiment with like different kind of machine learning models and then different AI services. The last one, which is again very important, is diverse skill set. We have our engineers continuously trained on these AWS services and technologies. We also complemented our team with data scientists who could help us choose the right artificial intelligence service or right machine learning model, the kind of tuning that we needed. Combined skill set, we are able to innovate and then move faster. To close it, change is the only constant in life. Your business may be changing, your customers may be changing, or the compliance environment in which you are operating may be changing. Artificial intelligence and machine learning helps you adapt to the change. AWS provides a platform to build scalable, reliable, and secure services. Thank you. Please complete the session survey.